Hey y'all, welcome to another open build. In this build, we're going to go ahead and build out the backend event watcher in order for us to actually listen for events on the Ethereum blockchain. So where we are so far is we have a basic front end built. We have our database layer in place. We're using Firebase for that. We are consuming the Etherscan's API to get all of the ABIs to our front end. And now we need to dive into the back end. So in our last video, we went through and we created a multi-user system using Firebase. So now we have this interface where we can go ahead and we can log in to the application, and we're going to see this basic interface that allows us to put a contract address in. So if we put in a contract address, like I'll go ahead and for this video, let's use the beacon chain deposit contract, which has a boatload of ether locked into it. And there's really only one event this contract fires, which is the deposit event. So let's see if I grab the contract address and I plug it in here, we're going to see the events available, and we can see that the deposit event is the type of event, is the only event that this contract emits. So I'm going to say, I'm going to listen to anytime somebody deposits, and we can go ahead and post to an endpoint. I'm just going to say test.com. Now, we don't actually have anything outputting to the screen yet that this is successful. There are some front-end adjustments that we need to make. And if anybody that's watching this is a UI UX designer that has some ideas, I'd love to hear them. Reach out and I'd love to chat. But let's go ahead and click Start Listening. And now this is going to go ahead and write an object with all the information we need to our Firebase collection here in the Firebase Firestore. And you can see here we just wrote that out, and now we have the contract address, the event object, the URL that we want to post to, and the user ID that actually created this listener. Awesome. So now everything's on the front end, writing to the back end, or writing to the database. Now we need a back end process to continuously watch the blockchain and listen for events. Now there are a ton of different ways that we can do this. What we're going to do today is we're going to use a hosted node service from Alchemy. And Alchemy is basically a service that hosts nodes at a basic level. They're writing a lot of really interesting API and SDKs on top of that to be able to do certain things like specific to NFTs and different transfer events and things like that. One of the interesting pieces is their Web3.js socket layer. So they have a library that allows us to connect to their nodes via a WebSocket, and it maintains some of the WebSocket connections for us. So what I'd like to do is try to leverage that for this. We do at Long Island Blockchain, we run our own nodes. So I am curious after we go through this to see if we can actually connect to our own nodes as well. We have some nodes running on our own network. So what we're going to do is we're going to develop a backend process. We'll write this in JavaScript, kind of keeping everything in JavaScript here. And let's see how this goes. So we're going to use Alchemy. We're going to read from the event router database on Firebase, and let's see what happens. So we're going to start fresh here. I'm going to go ahead and create a new project. We'll say, let's see, what should we call this? Well, I guess we'll call it the Web3 Event Watch. Whoops. We'll call it the Web3 Event Watcher. We could just call it backend, or we could be a little, excuse me, we could be a little snazzy and say Web3 Event Watcher D, right? Because this is going to be like a daemon process. So I'll go ahead and call it that. Okay, so now we have to bring in a couple dependencies. Okay, so what dependencies do we want? So first, let's go ahead and just initialize the project using npm. That looks fine. Let's go ahead and bring in, we're going to need the Alchemy project. So the Alchemy project is, if I could type this, Alchemy Web3. Let's see if I spelled that right. Now this is going to bring in the components. It's basically a Web3.js wrapper that allows us to manage WebSocket connections pretty nicely. We are going to use a WebSocket connection to our node in order to persist the connection so that we can get notified of events as they happen, which is really, really awesome. So we're going to bring that down. We're also going to bring down the Firebase admin library. Now this is going to allow us to connect to our backend database using the Firebase admin SDK. Oh, I should have put, did I not put save on the last one? I didn't. That's okay. We can go back and edit. Okay, the last thing we're going to need is, let's go ahead and bring in the .environment package. We're not using Node.js for the backend, so we have to be a little bit more explicit with this type of tooling. Awesome. Now, the last thing we're going to need to get started is we do need our Firebase admin service account credentials. Now, you could do this by generating from Firebase. If you click this little gear here, it'll take you to your project settings, and there's a service account tab. I'm not going to go into it because there's some private information in there, but you can generate a private key. And what that's going to do is allow you to download a JSON file, which basically just contains all of your credentials for you to be able to authenticate with your Firebase service. So I've already done that, and I have a copy of that on my desktop. So I'm going to go ahead and copy this from my desktop to this project. And I have it under the service account.json, and we'll just copy it right here within this project. So now we should have a couple different files. We have our node modules for the packages we just installed, and we have our service account.json. Let's go ahead and we're not going to put anything in it yet, but let's just go ahead and create our index.js. Okay, so now let's go ahead and open up our editor. Okay, I'm going to dive right into the index.js. And now there are a couple of things that we're going to need to do in order to achieve our goal, right? We're going to need to read all of the listeners that are available, right? So we're going to have to, read our listeners from the Firestore database. All right, we're going to have to listen for events. That's the big part, right? We want to be able to listen to events from the chain. Geez, I'm like I'm typing great today. All right, so, and we're going to go ahead and the last thing is we want to watch for changes to the listener database. So watch for changes in the listener database, right? Okay, awesome. Now, there are a bunch of other things we have to do here. We're trying to get to kind of a full proof of concept here, and there's a lot of different improvements we're going to probably make to this. So for each one of these, I guess we can create our own function that achieves all this stuff. But before we do that, why don't we go ahead and bring in some of the libraries that we're going to need in order for us to actually achieve this. So we have our admin SDK, and we're going to go ahead and require that. So we have our Firebase admin, and we're going to go ahead now and bring in the create Alchemy Web 3. That's going to give us that. Now we're going to also require our, we're going to go ahead and require our .environment config, right? Awesome. So we don't actually have anything in our .environment yet, but we will bring in our SDK keys, or Alchemy SDK keys, because we will need to connect to Alchemy. So awesome. So we'll have that. Now what we could do is we also need our service account object, which we just copied in. So we're going to say service account equals require, and this is just going to bring in that, what did we call it again? Just service, do we just call it service account key, or we called it a service dash account? So service dash account. Okay. Now we have pretty much everything we need to initialize our Firebase app so we can actually start to read data from the Firestore. So I want to go ahead and say admin.initialize app, and we'll pass in our credentials, which is going to be the service account, and that's pretty much all we need there. Okay, awesome. So that should be it there. Now we have our admin initialized. Now let's go ahead and grab a connection to our Firestore database. And yep, and then let's go ahead and create a connection to Alchemy. Now we will need to populate an environment variable with the Alchemy API key. I actually didn't do that before this, so we're going to have to go ahead and do that. But this is also, we also need to put our URL in here. So this is going to be a WebSocket connection to Alchemy. Now I did go ahead and register for Alchemy. I did create an app on Alchemy, and I'll show that off in a second. But we do need this URL here with the key right in the query string in order for us to connect. So that should do it there. Awesome. So now the last piece we're going to need here is we actually just need an array of listeners, right? We're going to basically be monitoring a big list of listeners. Now there may be other ways to do this. I'm going to do this in kind of a, I'll say a naive way at first, and then hopefully over time we can go ahead and improve this. So first we're going to go ahead and just say listeners equal an empty array. Awesome. So now we have an empty array of listeners. Nothing's there yet. We didn't actually go ahead and read our listeners. We're not listening for anything. We're not watching anything yet, but we do have some kind of global variables set up for us to be able to go ahead and do the operations we need. So the first operation is we need to read our listeners. Okay, so what does that mean exactly? That means we have to go out to Firebase and we need to go ahead in this collection, the listeners collection, grab all of the listeners that are in this list. And then we're going to go ahead and store them right within that listeners array. And then we can use that listeners array to set up contracts and listeners on the events we want to actually listen to. So in order to do that, why don't we just go ahead and create a new function. We're going to call this just read listeners, and we'll make it an async function. And yep, we're going to go ahead and grab a snapshot. Now this is interesting. One of the cool things about Firebase is the fact that we can get real-time updates kind of automatically when we set up these snapshots for these collections, which is kind of cool. So now we could say snapshot for each, and let's just go ahead and push the data for the doc that we get back onto the array. So now we have, once this runs, we should have an array of all of the listeners. Now we can go ahead and right off the bat start to test this by just calling read listeners, right? And we'd probably have to put this into an immediately invoked function because this is an async function. So we want to be able to maybe do our async or await, or we can put this in a .then or something like that. But I'd rather do this where we could just async. And I always find the syntax a little funky, but it does work well. We can go ahead and do that, and then we will read the listeners in here, and then we'll go ahead and close this. And then here's the funky part: we got to call it right away. So we're basically calling this anonymous function right away that we just defined, and it is an async function, which means now we can use await. So this is our immediately invoked function. I think we call this an iffy to run our functions. Okay, and you know what, let's put this all the way at the bottom here because we're going to fill this out with other functions as well. Excellent. So now we have that in place. Now let's go ahead and test this out. Let's try to run it. So I'm going to go ahead and we'll just start a terminal right within VS Code. And I'm just going to say node index. And oh, we're not actually outputting anything, so it's not going to show anything. So why don't we go ahead here in this in this function, let's just do a console.log listeners just to see them. There we go. So we got our listener back. Excellent. So that is working good. So stage 1 complete. Excellent. So we don't need to do that. And now we have our listeners populating. Now, the second piece of this is to listen for the events. Now, this is the meaty part. This is the part that we're going to have to use some Web3 JS APIs and instantiate contracts and things like that. So why don't we do the same thing? Let's go ahead and we'll create an async function. And we're going to go ahead and each listener, so listeners.forEach, we're going to go ahead and with our listener, with each listener, we're going to create a new contract. We're going to instantiate a new contract. Now, this looks pretty much correct. We're going to do new web3 ETH. We created the web3 variable up here. We have that capability. Now, listener ABI. So now this, we don't have this in our data structure, right? We just have the event, which is kind of a cool piece of ABIs, is that you don't need the full ABI to instantiate a contract. You only need the piece that you actually use. So in this case, we're only using this event. And luckily, we captured that section of the ABI exactly. So all we have to do here is instead of saying listener.abi, we could say, and this is actually, I believe, it needs to be in an array, we could say listener.event. And now it's essentially the ABI, but it's only the specific event we're listening to. And then the listener, I think we store this in .contract, right? Not, yes, .contract is the address. So we could say .contract. Awesome. So why don't we go ahead and console.log a little something to the screen. And we'll say listening for events on contract. Yes, okay, that's cool. We'll keep that way. Okay, now we need to go ahead and set up these actual listeners, right? Right now it just instantiated the contract, but now we need to use the contract, and we're going to go ahead and say contract.events, and then we need to index this by the event name. So we're going to say listener.event.name. And we're not going to pass anything into this. This is where we can, I think we could put filters for like the block numbers and things like that. Some folks have been commenting on that, which is awesome. And maybe we can extend this to achieve that. Say, I want to start on some block. I think there may be other ways we can do that, but we're going to say on connected. So we're going to listen to the connected event. This is a WebSocket connection. So we have these kind of subscription based systems in place. So we're going to say subscription ID, and we'll just go ahead and console.log, not that, we want to console.log the subscription ID, just so that you can see that we have a subscription ID. There we go. And now when we receive data, this is the big part. We want to say, all right, we've detected an event. Event, whoop, you won't yell it. Event detected. And we can put other debug information down here. We can also grab the date and time and things like that. But at this point, we actually detected the event. So we can put things like console.log event, the event name. We could say console.log, maybe the event data. And we can even console.log say the block number that we're on right now, right? Boom. Excellent. Let's go ahead and also grab the time. So we could say const now is equal to new date. Now might not be the best variable name, but let's see. And then we'll say, actually, no, let's do this. We'll say now UTC, and then we'll say new date. No, we'll stick this like this, and we'll have to convert that to UTC. So we'll say now UTC. We're just now calculating the actual time that we got this. We'll say get time plus, this is just to get the UTC time. That looks good. And then console.log UTC. Perfect. Okay. And now this is, well, you can almost look at this piece as the third piece in a sense, but so we'll call this the third piece. We'll call this the fourth piece, watch for changes. Because this piece is where we want to actually call the HTTP endpoint. I may do this in a separate video because I could see I'm on 20 minutes already. Because just testing this whole thing is going to be interesting because we're listening to mainnet events and we don't have anything really. We'd have to sit here and wait for an actual event to happen, which may not happen right away. So we're going to get this running. We'll get this listening. Oop, there's a little issue here. But we're going to probably do another video here where we actually test. Maybe I'll deploy a little test contract, or maybe we'll use the testnet for this. But this is where we can then go ahead and fetch, go ahead and hit the endpoint. And we can pass in some information here if we wanted to, right? We'll go ahead and pass the data that comes back from the event, return values. We could even throw in the block number. That's not a bad idea. My trusty AI. And I don't think we called it endpoint, did we? We called it URL. So it's going to be listener.url. And that should be it. And we just need to close this. We'll say on error. Console.log error. We'll close that. And I think that is pretty much it. All right, that's going to close this. Now we need to close this. We do need to close this. So many curlies and parentheses everywhere. Okay, so that is that method. So let's just recap that real quick. So we're listening for events. We're looping over this array of events that we've read from Firebase. And then we're instantiating a new contract for each event that we're listening to. And then we're connecting to Alchemy through a WebSocket in order for us to listen for the specific event that we're listening for. And then we're going ahead and posting to the URL that we've specified the information that came back from that event. Awesome. So this should work. Now what we need to do is we need to go ahead and actually call this bad boy. So we're going to say await, listen for events, boom. And now the last piece of this, and this is where we'll probably end this video, is the last piece of this is going to wait for changes. So we need to wait for changes. When people add a new listener, we need to go ahead and actually recreate this list in order for us to actually listen to that event. So let's go ahead and create another method here, and we're going to call it wait for changes, and we'll make that async. And now what we're going to do here is we're going to say db.collection, and we're going to listen to the DB event. Now this is that method, the onSnapshot method, that allows us to basically listen for changes to this database. We're doing a lot of listening in this application, which is kind of cool. So we're going to make this async and go ahead and bring the snapshot in here. And let's close that. And let's close this, just okay. And now inside of this, what we're going to do is we're going to say console.log change detected. And yeah, awesome. So that's pretty much it. Now there's definitely a better way to do this. maybe if we index, maybe we don't use an array, maybe we use more of a dictionary or something like that, where we can just insert and delete certain event listeners. In this, the way I'm doing it here is we're recreating the entire array every time. So we're going ahead and saying, hey, a change is detected, make the length of the listeners array 0, then go ahead and repopulate that array with all of the listeners again. So it's going to basically, like, remove everything and then re-add everything. If this was a really large database of listeners, this is not the way to do it. Right now, this is a proof of concept. We're just getting off the ground here. We're experimenting, we're learning. So this is okay. But this is definitely, there's a fair amount of room for improvement as we think about scaling an application like this. There are a couple other things too, in terms of like using Alchemy for something like this. This may get expensive because we have so many WebSocket connections connecting to that node. It's one reason why I'd like to try to use our own node for this, which would eliminate that cost. So yeah, this is so now all we have to do here is do the same thing, watch for changes, and that should be it. That should be all the core components we need in order for us to support this type of design, which is right here. So this back-end event watcher has a WebSocket connection to Alchemy. We're listening for events in the database. Let's go ahead and try to run this and see what happens. So let's go to new terminal and boom. And there we go. We're listening for events for the contract. It did read a change, I guess, when it first ran, because we called it right away. And now we're sitting here waiting for deposit events on the Ethereum beacon chain contract that takes the deposits to be a validator on Ethereum 2, which is kind of crazy. Now, when we receive this event, which probably won't happen in this video, it will execute this on data call here, and we should see event detected, and we'll go ahead and post to this. What I'd like to do in the next video is I may contrive a simple smart contract that we can deploy and go ahead and actually create the events ourselves so that we can cause these firings to happen. And then we're going to go ahead and test to make sure that we're actually hitting the URLs that we're declaring here. We'll probably use like a paste bin or something like that to test that, just to prove that the HTTP messages or posts are actually executing. All right, I'm going to go ahead and create a separate GitHub project for just this project. And what you could do too is to run this. You could put this inside of like a nodemon, so you can use the nodemon project to keep this running. So like if this crashes on a server, it's going to stop. But if you use nodemon, it'll keep respawning it and running it. So just one way to kind of set up the infrastructure to run something like this. But yeah, pretty cool stuff. I wish this would happen as I'm recording this, but I'm sure it will not. I'm kind of curious now. If we go here, how often does this get a deposit? So the last deposit was 1 hour ago. So it looks like maybe every couple of hours we're seeing a deposit. And look at that, all 32 ETH, drop it in. But all right, guys, so I hope you enjoyed this. In the next video, we're going to go ahead and test this further. I'm going to set up some test cases for us to be able to test this out. And if you have any comments, any improvements, please let me know in the chat. If you're enjoying this, please subscribe. Really having fun doing this. And we're just about there with a full proof of concept for a Web3 event listener. All right. Till next time. Have a good one. Bye-bye.